We're going to take a look at systems of equations. A system of equations is a set of two or more equations. An example of a system of equations would be these two, negative 3x plus 2y equals 8, and x plus 2y equals negative 8. That is a system of two linear equations. A linear system consists of linear equations, equations that when graphed they form a straight line. And the solution of a system is where the two graphs meet. It's a set of values for the variables that makes all equations in the system true. In other words, it's the point at which the lines intersect. So we're going to be solving a system of linear equations. And when you solve a system of linear equations, you're simply finding the point of intersection of those two lines. It says, what is the solution to this system? So we're going to take this system, negative 3x plus 2y equals 8, and x plus 2y equals negative 8. We're going to solve that system. We're going to find the point of intersection of those two lines. Those are two linear equations. We're going to find out the point of intersection of where those two lines meet. So to do that, we're going to solve by graphing. We're going to graph each line and then visually look and see where those two lines meet. So to graph those two lines, probably the easiest way is to get them each in slope-intercept form. Take that first equation, negative 3x plus 2y equals 8. Slope-intercept form is y equals mx plus b. So you want to solve this for y. Add 3x to each side. You have 2y equals 3x plus 8. Then divide each side by 2. You get y equals 3 halves x plus 4. So you can see the slope and the y-intercept. The slope is 3 halves and the y-intercept is 4. So to graph that, put a point at 4 on the y-axis. That is the y-intercept. And from there, go up 3 into the right 2 and put another point and draw a line through those 2 points. That is the graph of this negative 3x plus 2y equals 8. Then right on top of that, graph the other equation, x plus 2y equals negative 8. So to graph that, get that in slope-intercept form, y equals mx plus b. Subtract x from each side, end up with 2y equals negative x minus 8. Then divide each side by 2. When you divide each side by 2, that negative x divided by 2 would be negative 1 half x, so you can see the slope. And negative 8 divided by 2 is negative 4. So y equals negative 1 half x minus 4. Slope on that is negative 1 half, and the y-intercept is negative 4. So to graph that, put a point at negative 4 on the y-axis. And then from there, the slope is negative 1 half. Go down 1 to the right 2, put another point, and then draw a line through those 2 points. So you can see these two lines do intersect at a specific point, and that point is negative 4, negative 2. That is the solution to that system. Now what that means is that's the point that those two lines share. And you could check that. If x is negative 4 and y is negative 2, to check this, put negative 4 in for x, negative 2 in for y into each equation, and you get a true statement in both equations. So if you take that first equation, put negative 4 in for x, and negative 2 in for y, you'd get 8 equals 8. That's a true statement. If you put negative 4 in for x and negative 2 in for y into the second equation, you would get negative 8 equals negative 8. And that is also a true statement. So that would verify that negative 4, negative 2 is the point of intersection. But with a graphing calculator, or even on paper, you can easily see that the solution is negative 4, negative 2. We're going to find the point of intersection of these two lines. In other words, we're going to find the solution to that system. Now, there are other ways to find the solution to a system other than graphing. There's what's called the substitution method or elimination method. We'll cover those ways later. We are going to solve this by graphing. So we're going to graph each equation, take that first equation, 2x plus 4y equals 12, and get that in slope-intercept form. So to get that in slope-intercept form, subtract 2x from each side, end up with 4y equals negative 2x plus 12. Remember, slope-intercept form is solving this for y, so you can see the slope and the y-intercept. Divide each side by 4, end up with, if you divide negative 2x by 4, that would be negative 1 half x, and if you divide 12 by 4, that is 3. So the slope on this is negative 1 half, and the y-intercept would be 3. So to graph that, you start with the y-intercept, put a point at 3 on the y-axis, and then from there, the slope is negative 1 half, so go down 1 to the right 2, put another point, and draw a line through those 2 points. That is the graph of 2x plus 4y equals 12. Take that second equation, we're going to graph that by getting that in slope-intercept form. Subtract x from each side, end up with y equals negative x plus 2. Then you can pick out the slope. The slope is the coefficient of the x. The number in front of the x is negative 1, and the y-intercept is 2. So to graph that, start with the y-intercept. Start at 2, put a point at 2 on the y-axis, And then from there, the slope is -1. Now, as rise over run, remember that's -1 over 1. So go down 1 and to the right 1, put another point, and then draw a line through those 2 points. Now, you can see where those 2 lines meet. They meet at the point -2, 4. So -2, 4 is the solution to that system. In other words, that is the only point that those 2 lines share. And if you take those coordinates, -2, put that in for x, and 4 in for y, into each equation, you would get a true statement in both equations. I'm going to take that first equation and put -2 in for x, then 4 in for y. You get both sides equaling each other. You end up with -4 plus 16, that's 12. 12 equals 12, that's a true statement. That means -2, 4 definitely lies on the graph of that first equation. Take the second equation, do the same thing, substitute -2 in for x and 4 in for y. If you do that, you end up with 2 equals 2. So again, that's another true statement. And that means that that point, -2, 4, lies on the graph of the second equation. So you can visually see that -2, 4 is a solution, is the point of intersection. And you can check that by putting -2 in for x, 4 in for y, and getting a true statement in both equations. So the solution to the system is -2, 4. Which ordered pair of numbers is a solution of this system? 2x plus 3y equals 12 and 2x minus y equals 4. Well, let's say he doesn't feel like graphing. You can easily substitute the x, y values into both equations, and if it makes a true statement in both equations, then you do have the correct solution. For example, just take one of these points. Let's say -3, 6. So you're just trying your luck here. We'll take this point, -3, 6, substitute -3 in for x and 6 in for y. It has to make a true statement in both equations for that to be a solution. So if we put -3 in for x and 6 in for y into that first equation, you have 2 times -3, it'd be -6. 3 times 6 would be 18. So -6 plus 18, that is 12. 12 equals 12, but you don't stop there. Yes, that point, -3, 6, works in the first equation, but all that means is that point lies on the graph of that first equation. For that to be the solution, it has to lie on the graph of both equations. So we'll check that second equation with the same point. Put -3 in for x and 6 in for y. You'd have 2 times -3 minus 6 equals 4. It'd be -6 minus 6 equals 4. Well, -6 minus 6, that is -12. -12 doesn't equal 4. So what we have there is we have a point that lies on the graph of one equation, the first one, but it does not lie on the graph of the second equation. So that couldn't be the solution. There's no way that can be the point that those 2 lines share because it doesn't lie on the graph of the second equation based on that. So I'll pick another point. This time let's go 3, 2. If we put 3 in for x and 2 in for y into that first equation, we end up with 6 plus 6 equals 12. Well, that's a true statement. 12 equals 12. But it has to work in the second equation. So if you put that point 3, 2 into the second equation, 3 in for x and 2 in for y, it'd be 6 minus 2 equals 4, which it does. 4 equals 4. That is a true statement. So that point, 3, 2, works in both equations. That means that point lies on the graph of both of these lines. So that is the solution. X is 3, y is 2. Which of the following graphs shows the solution to the system? So this time you're looking at the graphs and you're going to decide which of those graphs matches the solution to this system. I would take each of those equations and I would break them down into slope-intercept form so you can see the slope and the y-intercept, and then you can match that up with one of those graphs. Take that first equation, x plus y equals -4. To get that in slope-intercept form, subtract x from each side. End up with y equals -x minus 4. So you can see the slope, that's the number in front of the x, it's -1, and the y-intercept, where it crosses the y-axis, that is -4. Well, there are 2 graphs that show a y-intercept of -4 and a slope of -1. Remember, a negative slope will go down and to the right. So this first graph A has a y-intercept of -4 showing. Letter D down here has a y-intercept of -4 showing, and they each have a slope of -1 along with that y-intercept of -4. So it could be A or D. Let's take the second equation, 2x minus 2y equals -8. Get that in slope-intercept form. Subtract 2x from each side. You end up with -2y equals -2x minus 8. And then divide each side by -2. So if you divide each side by -2, you get y equals x plus 4. Now the slope on that, it's the number in front of the x, coefficient of the x. The slope is 1. That means the line would rise 1 for every 1 it runs to the right. And the y-intercept is 4. So you're looking for a y-intercept of 4 with a slope of 1. this graph here, this black graph, has a y-intercept of 4 and a slope of 1. And so does this one over here, y-intercept of 4 and a slope of 1. Remember that graph down there, letter D, we matched that gray line up with this first equation, and the black line matches up with the second equation. So the one that shows the solution to this system would be letter D. You and your friend are both knitting scarves for charity. You knit 8 rows each minute and already have knitted 10 rows. Your friend knits 5 rows each minute and has already knitted 19 rows. When will you both have knitted the same number of rows? You're going to start off by letting x be the number of minutes and y being the number of rows. We're going to create a system of 2 equations. And with that system of 2 equations, we're going to match your knitting job and make that into one equation, your friend's knitting job into another equation, and we're going to graph that system and see where those 2 lines meet. And where they meet, where y is the same, the x value, that will be the number of minutes. You knit 8 rows per minute and already have knitted 10 rows. So you're starting with 10 rows, 8 rows per minute. Remember, x is the number of minutes. So 8 times x, that is 8x, plus 10. Y is the total number of rows. So for your knitting job, it's y equals 8x plus 10. Your friend, on the other hand, has knitted 5 rows per minute and has already knitted 19 rows. So we're starting that person off with 19. 5 rows per minute, that's 5 times x. Remember, y is the total number of rows, so y equals 5x plus 19. That's the equation that matches your friend's job. So we're going to graph those 2 equations. A little tough to do on paper. You may want to use a graphing calculator. If you graph those on a graphing calculator, you might see something like this. Scroll up to where they meet and then zoom in and decide precisely where they meet. Maybe some sort of a trace function on the calculator, or just pinpoint exactly where they meet. They're going to meet at the point 334. So where x is 3, y is 34, that's where those 2 lines meet. In other words, in 3 minutes, you both will have knitted 34 rows.